A numerical on unsteady flow process in thermodynamics and asked in the GATE examination during the year 2021 is solved. The problem statement and the figure accompanying that are shown here. You can read. Data given are initial pressure Pi is 250 kPa, initial temperature Ti is 400 Kelvin, tank final pressure P suffix F is 250 kPa, Cp and Cv values are given, gas constant value is given, since the tank is initially evacuated, mass initially is 0, and when the valve is closed, the air that enters the tank is 0. Therefore, mass m suffix e equal to 0. We need to find out what is the final temperature of the air inside the tank. If you take a close look at this problem, there are two things. One is a supply line. So this is the supply line. And the condition of the supply line is denoted by suffix I. Say, for example, I is the initial condition. And the other subscript used is E, meaning the air exiting the wall. The other one is a tank. Of course, in order to solve this problem, we assume a control volume over this tank. And the condition of the system, that is the control volume, are represented using subscripts 1 and 2. 1 is the initial state, 2 is the final state. This problem is an unsteady state problem. Like steady flow analysis, unsteady flow can also be analyzed by applying mass balance and energy balance. Therefore, in the solution, first we will look for mass balance. What is that mass balance? Mi minus Me. I and E subscripts stands for supply line, the conditions in supply line. So there is a wall separating the supply line and the control volume. So Mi is the initial mass that is entering the control volume when the valve is opened. Me is the final mass of the air through the valve when it is closed. So Me. is equal to M2 minus M1 suffix CV. CV stands for control volume. M2 is the final mass of air inside this control volume. M1 is the final mass of air, initial mass of air inside this control volume. Initially, the control volume is evacuated, therefore, M1 is 0. When the control volume or the tank pressure reaches 250 kPa, the valve is closed. When the valve is closed, the mass of air entering through this valve into the control volume M suffix E is also 0. This gives Mi is equal to M2. This gives Mi equal to M2. Now, we will apply the energy balance equation. For an unsteady flow process, energy balance is given by Q minus W is equal to change in enthalpy plus change in internal energy of the control volume. This enthalpy are denoted using the subscripts E and I. Therefore, they represents the supply line, and here 2 and 1 represents the control volume. In this equation, as per our earlier discussion, we can substitute 0 for ME and M1. Also, there is no involvement of heat transfer and work transfer. It is insulated. There is no heat transfer and no work is done. Simply the air flows through the valve. That's it. This gives us Mi Hi is equal to M2 U2. Earlier we discussed Mi is equal to M2. Therefore, we can cancel Mi and M2, which yields Hi is equal to U2. What is this Hi and U2? Hi can be written as C suffix P multiplied by T suffix I. U2 is C suffix V multiplied by T2. That is enthalpy is equal to specific capacity multiplied by the temperature, and internal energy is equal to specific capacity at constant volume multiplied by temperature. Cp, Cv, Ti are given. The only unknown here is T2. Of course, our aim is to find T2. Substitute the values. We get T2 equal to 559.9 Kelvin.